You don't see pH, but it's everywhere in your drinks, your skincare, even your mood swing. Volumetric analysis, that's how we catch it in action. This presentation isn't served by one beaker alone. It's the work of a whole labs of mind, each adding their drop into the pH story you're about to hear. Let's talk about volumetric analysis, a fundamental method in analytical chemistry. Basically, it's a quantitative technique that we use to determine the concentration of an unknown solution by reacting it with another solution whose concentration we already know. The reaction usually happens in a control volume, hence the name volumetric. There are four main types of titration under volumetric analysis, each with a different type of chemical reaction. First, we have acid-base titration, which involves a neutralization reaction between an acid and a base that is very commonly used in labs. Second is redox titration, where oxidation and reduction occur. So, there is a transfer of electron involved. Third, there is complementometric titration, which is used especially for metal ions. Here, a complex or chelate is formed, usually using ether. And lastly, precipitation titration, where a solid precipitation formed as part of the reaction, often used to test for halide ions like chlorides. Alright, moving on to pH, which is a super important concept in chemistry and daily life. So what is pH? The definition of pH is that it's a scale used to measure how acidic or basic an aqueous solution is. Chemically, it's calculated as the negative logarithm of the hydrogen ion concentration, which is written as pH equals to negative log H plus. Now, let's look at the scale itself. If pH is between 0 to 6.9, the solution is acidic, meaning it has a high concentration of hydrogen ions. A pH of 7 is considered neutral, like pure water. And if the pH falls between 7.1 to 14, it's basic, or also called alkaline, meaning it has more hydroxide ion. Why does pH matter? Well, the importance of pH can't be overstated. It affects human health. For example, blood has to stay around pH 7.5 to function properly. It also impacts for our environment, like how acidic rainwater can harm aquatic life, and in industry, pH influence product quality, especially in food, cosmetics, and pharmaceuticals. So yeah, pH isn't just a number, it's a signal of chemical balance, safety, and also quality.
In overall chemistry, especially when studying pH, it's important to understand the theory behind acid-base titration. Acid-base titration is a method used to find the concentration of an unknown acid or base. This is done by slowly adding a solution of known concentration until neutralization happens. There are a few key terms to know. The equivalence point is the moment when the number of mole of acid equals the number of mole of base. The endpoint is when the indicator change colors. This shows us that the neutralization is complete. What is the indicator? The indicator is the special dye that change color around the endpoint, helping us to see when the reaction is done. The basic formula used in titration is MAVA equal to MBVB, where M stands for molarity and V stands for volume of the acid and base. A and B specifically for acid and base. Understanding this helps us in many daily life situations like testing the water quality, checking food acidity, or even formula skincare products.
Now, let me explain the methodology we follow in this experiment, which is a standard acid-base titration process. Phase 1. First, we prepare the standard solution with a known concentration. This serves as our reference for determining the unknown concentration later. Phase 2. Next, we fill the burette carefully with the standard solution, ensuring there were no air bubbles that could affect the accuracy. Phase 3. After that, we measure a fixed volume of the sample solution using a pipette and transfer it into a clean conical flask. Phase 4. Then we added a few drops of a suitable indicator to the flask. The indicator helps us visually detect the endpoint of the titration by changing color. Phase 5. In this phase, we titrate by slowly adding the titrant from the burette into the flask while continuously swirling it until we observe a distinct color change indicating the reaction endpoint. Phase 6. Once the endpoint was reached, we recorded the final burette reading to know exactly how much titrant was used. Phase 7. Finally, we use this data to calculate the unknown concentration of the sample solution. This step-by-step methodology ensures our results are accurate and reproducible.
Now, let's move to the other part, which is the sample of titration result to illustrate the concept. In this example, we are determining the concentration of acetic acid in a vinegar sample. We start by measuring 25 milliliters of vinegar and titrate it using 0.1 molar sodium hydroxide. The endpoint is reached after adding 30 milliliters of NaOH. Using the titration formula, which is M1V1 equal to M2V2, we substitute the known values, which is M1 times 25 equal to 0.1 times 30. Solving for M1 gives us a concentration of 0.12 molar. This tells us that the vinegar contains 0.12 moles of acetic acid per liter, which helps us to determine if it meets the expected quality and acidity standards.
Here are some examples of how pH can affect our daily lives. First of all, food. pH is responsible for most of our daily food, such as ensure proper acidity in vinegar, preparation of sauce, and fermentation of dairy products, such as cheese and yogurt. They also take place in water treatments, which maintain safe drinking water pH. pH also take an important place in agriculture. It is important to adjust a soil pH for optimal crop growth. A soil that high in acid nor base is not suitable for plant to grow. Not to mention health and beauty. pH balance soap and shampoos to protect skin. If a healthy product contains high of acid, it will leading to dryness, and if it high in base, it will cause irritation. To summarize our presentation today, volumetric analysis is vital precise chemical measurement. Acid-base titration is a practical method to determine pH, and understanding and controlling pH is very important for health, industry, and the environment.
To close our presentation, here is a list of references that support everything we have shared. From the explanation of acid-base titration to the role of pH in daily life, all the information is based on reliable and trusted source. We hope this presentation has helped us better understanding how pH plays a very important role in our daily life. Thank you.